the another interesting thing in AI, which is sometimes what we are processing is not just an independent image. So what we have seen and understood that AI works like a black box. Okay, so a lot of millions of parameters are there, and you don't know what they are doing, kind of thing. All you care is that you have like some million data samples. They all are annotated. Annotated mean whatever you want the box to tell. So every sample, you know the answer. Gigi.
Sir, I want to talk about the project.
Gigi,
So
please.
when we are appearing for the final exam.
Final exam is I think now we are in actually week 13, right?
Yes. Yes,
So
sir.
though this is week 12, but there was a midterm, so week 13, then there is a week 14, then there is a week 15, then there is a week 16. So 13 has gone. So I think it is after 4 weeks, 1, 2, 3, 4. So
I think, sir, because we are also doing the assignments and covering the lecture and final exam. So I don't think
I
so. It is a the subsequent a good time for us to complete the project. So I'm afraid that the timeline is
I
very strict
will.
timeline.
I think there is a month, so I will not give you any more assignment now. Okay. So a project means almost, let's say, 4 weeks of work.
Okay.
I don't expect like too much. I expect like it's like 4 assignments.
Okay. So but you have given today assignment 7
Let's
already.
cancel that. So I'll solve. I will do it myself, the assignment, and I'll show you the result. Okay.
Okay.
So this assignment you don't need to do it, but I'll just experiment it myself and I'll show you that how it worked, because I myself don't know that how it is going to turn out, will be turned out. So let's just start focus on the project, and not don't make a very complex project. Just assume that it is just 4 assignments or 3 to 4 assignments worth of complexity. And especially now, once you have like 1 to 3 students, so you can safely say the good project will be like 6 assignments worth of work if 3 people are doing it. Okay. So, but I expect at least 3 to 4 assignment worth of complexity in the project.
And the same thing that after your approval, then we can start work on our project.
No, you can just start. I'm not going to reject anything. All I can do is I'll just try to refine it further. But you can just start working on the project as long as you know it has all these elements. I don't mind, and try, because we are here. We shall be just using ChatGPT to generate the code. So, or you can even, I don't know, copying a project is not good. So I want you to just think something, you know, out of the box, good thing, interesting thing, and try to do this project yourself, because we are not expecting anybody to write the code. So uh, just try to come up with an interesting idea, and
Okay.
and don't mind to complete it. I mean, I really, it's okay that if you even don't able to complete it, just have a good idea, make a good presentation, and see these are the components that you could able to accomplish. So I'm not expecting, you know, everybody's project working. I am just expecting people to critically think of interesting applications.
Okay.
Okay. Or even a
And my
little.
last question. And my last
Gee,
question is that is case is going to support anything financially for the publication?
this I need to see that if there are something like very good publications in, but you know, out of a course, it is very hard to get something published in, for example, IEEE transaction or so. So let us see. I mean, one way is there are many conferences in Pakistan, so we can send
Yes.
them here, and this case can support. If like you're publishing something in a conference, in an international conference which is happening in Pakistan, definitely we will support that.
Okay, great.
Okay.
Thank
With
you.
the
Thank you.
okay. So this is called deep sequence modeling, and we'll just start today, and then we'll spend more time on this. So, in if you have a picture, for example, if you want to predict the direction that where this ball will go, you cannot, because you have only just one frame. So one frame would not tell you that where this thing is going. But if you have like previous multiple frames, and then you know that where this thing is going to go, and you can guess if you have a sequence of things happening. And those sequences are very important, because sometimes voice is a sequence of words: eat your raisins outdoors on the porch steps. So sometimes, because if you know, now they can even using the CNN or RNN, they could actually able to generate music which was left incomplete by the creator of the music. And they're doing very interesting projects, because now if you could just model it correctly, and you can just generate that thing in a sequence. And that's what all the large language models are about, that they are just doing the sequence deep learning, and they just keep generating the next and the next and the next word in the sequence. So the sequence are important. ECGs also, because sometimes you got to, for example, just heart rate variability or TT alteration. Sometimes the doctors would see that what is this T and T waves are, these are inversions or so. Sometimes even doctors, once they are kind of diagnosing, they look at the whole thing. And so is the a neural network. If it is some annotated data, it will also able to learn from the sequence. So sequences are important. Sequences are important in stock price prediction. We also developed a very interesting thing, which was a Bitcoin predictor. And Bitcoin predictor also, we use different prediction algorithms, but it was a high frequency trading platform, where every 1 minute you get a data that how the Bitcoin is performing, and then you can generate an event whether to buy or sell. Okay, whether to buy or sell, very little part of the Bitcoin. And so you do seeing different smaller variations which are happening at on every minute, and you can just make use of that to make a little money by having a predictor. So these are also like kind of projects. If you want to, the Bitcoin data is available on the internet, you can get just this data and do a project which is do that. So sequence modeling has many applications. What we have seen up till now is kind of this, where you have this black box, so to say. So it is colored in green, but this is kind of a black box, which is maybe a CNN or any other algorithm, as a matter of fact. So you input E and you get some expected or predicted output Y. But in many applications, for example, just we discuss about sentiment classification, where you are writing Dunkin' Donut, I ate your donut and I am sick from last 2 days. Okay, so now the Dunkin' Donut was, somebody has tweeted this, and if like something who is very important and who has millions of followers, he writes something like this, then Dunkin' Donut needs to find out that their brand is really going to be severely damaged. So these are the type of applications where you do sentiment classification. You have many words, but end of the day, you want to find out whether somebody is saying positive or negative about you. Okay, so this is many to one classification. Then image capturing, like the image I showed you, a footballer is kicking the ball with his complete force. Okay, so you want to give an image, and you want it image to be captioned that a football player is kicking a ball. Okay, so this is you input one, and you get many output. Another is where you have many to many. So this is translation, that you write, I love Pakistan. Okay. So in Urdu or Arabic, it gets translated into this. So this is where you have many to many. So all these are different applications of deep sequence learning and modeling. So if you go back and learn about, just recall uh, for uh, this case where you just have one input. One input means that this is X, but X has like multiple features, and it is giving you Y also has some dimension. So this is a perceptron where you have simple one perceptron, all these weights, and these are the three features. And then you multiply. Here Z is, you multiply and add them all together. X1, this is feature number 1. X2 is feature number 2, and similarly. So Z, and then you put Z through this nonlinearity, which may be a sigmoidal nonlinearity, to get Y. Okay. So a feed-forward network we have seen where, and now this is interesting. So you have this input, and so you have this input just goes once and get out. So this thing has no memory. This thing has no memory in it. So it does not remember. It has just weights being trained. So this network is trained on these weights. So these are 3 by 4, 12 weights. And then it just generates an output. You change the input, the output is changed. In case that you want this network to remember what was fed to it, you got to put a memory in it. Okay, you got to put a memory. So this whole thing must get into a memory. Okay, so that if you have now the new input, and whatever decision was done or whatever excitation was there in the last, you also make use of it. Okay, if you want to make it recurrent. So this is what actually it is, that this black box has no memory. So it has no memories in it. It has fixed weights. Memory is something where you can uh, just store, and every time the values can change, but the weights are fixed, so the values are not changing also. So all the weights are fixed. You can even put them in a ROM instead of a RAM, or you can hard code them if you have just a fixed model. So input comes in, you get an output, and there is no memory. Input dimension is there are M numbers, output dimension is there are N numbers. Okay, and now somehow you have a sequence. Okay, so you have, let's say, uh, images like we did. You can always convert a video into multiple images, and you want to find out that what all these the sequence of images they are doing. So the best now we are equipped with, you put one frame here, it will tell you what it is. Put one frame, it will tell you what it is. You put another frame, it will tell you what it is. And usually a classification is only it can tell it is a banana, it is a car, it cannot say the car is moving fast, it will hit this. So it can only tell you that there is a car, there is a motorbike, or So so simply we have this neural network, which is a mapping, and it's a highly nonlinear mapping which take this input, and it has some weights and this nonlinearity function, and it creates an output. So every time you have an input, it has an output. So that's very simple. So you have at time 0, you have time 0 output, you have time 1 input, you have time 1 output, time to time. And so that's how it's just working, and there is no relation between each other. And what we want, that it should have relationship. Okay, so somehow it should have a memory where it stores its some internal state, that this is what it has extracted from this image, and it should send it to the next And if it is a separate neural network, so this neural network or this black box should accept two type of inputs. One input is coming from the adjacent black box and the input. So knowing this and knowing this, it can say something. And similarly, now it should again have some memory, where this memory has the effect of this memory as well. And whatever their decision, they have taken this memory as well. And they say, okay, based on this new input and this input, and yeah, so this internal state and internal state of this, I have this. Or this internal state updates this internal state in a manner that only this internal state is fed to this block. So individual independent inputs can be handled, but this capability is not there in whatever we have learned so far, where some internal state, some output is to be sent to the next. But you cannot have, because you are not sure that how many sequence of images, how many words in a sentence you are going to have. So you cannot just design something of arbitrary length, because every network is so complex. We know there are like millions of parameters here. As we have been seeing 70 million, 78 million. So it's not even possible that you have many of these concatenated, and even you don't know that how many should be there, because you don't know that how big a video are you going to study, or how big text are you going to study, or so that's the reason that you cannot just make it infinitely long, and you cannot just have so many of these concatenated with each other. So now you kind of got to compromise on something. And what you do is that, and secondly, now every time your output is based on the current input and the previous state, which this is I am calling memory, or I am calling previous state. It's kind of like an IIR filter. If you remember an IIR, in infinite impulse response filter, it has an input. So at time n, there is an input. It multiplied by some coefficient b naught, and you have, this is your output at y of n, and then you store the previous output. And then these are the parameters. You multiply the previous output with A1, and then that is something you add into the input. So your input is so your output is a function of the current input, okay, and the previous output, and some parameters which are getting into the systems to give you the desired output. So it's almost kind of the same thing, that you have this, and at the same time, I should say, you are also updating h of t. So you have h of t now for the next cycle. So this is how then recurrent neural networks. The best thing is that you have a memory like IER filter. So you store it here, and then you come back and update the memory like that. So you are, every time you get a new input based on what you have, which is the memory and the input, you generate an output, and you generate the next state, which is h of t. So this thing has uh, that's how you basically build a neuron, or which is has a recurrence in it. So if you just lay out this, though it is, as I mentioned, it is not like this, it is actually like this. So you have this is generating two outputs. This is like a hidden state. These are like a hidden state, but stored in some memory. So they are not just, previously you don't have to save any state in anywhere. It will just go up and you get output. So no neuron has to be stored. No value in any neuron has to be stored. Now you are saying, something has to be stored as memory. So you store them. So you say, okay, these are the values, and whatever those neurons are, the intermediate representation, you store them. Okay, and that is something that you got to use them to generate an output and keep using it. And effectively, it looks like this. Okay, this is the past memory, this is the input, this is the output, and obviously you are going to generate the new memory. The memory gets updated on every. So here is kind of the idea that this is input layer. Let's say this is a hidden layer. These are the hidden layer, or these are the outputs. And now you are saying the hidden layer is to be stored in memory. Maybe all of it, maybe some of it, but you don't know. Let's say it is stored in memory and it has to be updated. So based on the input, maybe here is some states. So these inputs are also going here. And this is the state which is to be updated again. And it is being used by the network. So it is it's a representation like, so you have weights B, you have weights C, you have weights A, and but this states keeps on getting updated and keep on being used to get the output and for their own updation as well. So this is like all these internal states now have memory and they just keep getting updated by the different inputs that you get. So you are generating output and also you are updating the states, and so there are more weights into this. So same thing, like the weights, but this is only one set of weights. So this is important, that you cannot just have like this figure may mislead you that you have different set of weights here, then different set of weights here, different set of h here, or weights here which is producing this h are different. But so this C is going to be fixed. So C is fixed, and A, so weights are fixed. So weights are fixed. A is fixed, B is fixed, C is fixed. So all these weights are fixed. So this is where a good depiction of, again, the same, that you have the memory, the internal states which you are updating, and your outputs. Now you have different sequences, your first sequence, the second sequence, the third sequence, the fourth sequence, then fifth sequence, and you don't care how many you are going to get. Okay, you don't care how many you are going to get, because it's recursive. Recursive can work till infinity. Okay, so even infinite many things, but it may just start losing. So remember, like this, so it may start losing the very first sequence, the impact of very first sequence slowly, because it has to be updated based on the new inputs, the new inputs, the new inputs. So that is something we will see, that how that basically happens. So this is called the recurrent neural network. And here is this black box is just updating itself, recurrent neural networks, where you have to update the state and the output. So there are the weights. Weights basically use to have the recurrence relationship. So this is a recurrence relationship, as once you write y of n is equal to x of n plus a y n minus 1. So this is the recurrence. It's the previous, then the previous becomes the current, current becomes the previous. So this is a simple first order difference equation. But here is a bit more complex, because there are weights and weights are to be learned, and the training is again going to be very, very complex. So so state gets updated at every new input that you have. Each time step, the state gets updated. So this is a function which is the weights and the input and the old state. So there are three things running into this whole thing. Their weights are to be trained, and the input and the state. So more clearly, this is the equation. So there are weights which we are calling to update h, these set of weights, and then the h and x, these set of weights. So you multiply these weights with the input and these weights with the previous state, then you add these two together and put it through the nonlinearity to update the state. So now the state has the previous input and the previous state and the current input and the weights. And now this is again a big efforts that you got to do to train all these weights. Now, first there used to be only one set of weights. Now you are going to have two set of weights. So one set of weights is for these updating the memory. Another set of weights is to multiply it with the with the x. So these are called recurrent neural network. I think I can just stop here because it's a little complex. So we will just take it to the next class. But